Welcome to Lesson 10, Comparing Functions, and this is page 19 in your functions packet. So rate of change is very important when we're trying to compare functions. We can compare functions by looking at their properties such as the slope or the rate of change. To find the rate of change, we use the slope formula, which is y2 minus y1 divided by x2 minus x1, or we can compare the ratio of rise over run. And another way to say this is the change in y values over the change in x values. So this says practice finding the rate of change for the following example. So we're going to look at 4 different scenarios. The first example, all we're given is an equation. And if you recall, when we're given an equation, we can find the slope because we have what's called a slope-intercept formula. So the m, the coefficient of x, the number in front of x, is the slope, also known as the rate of change. So the slope in this case is 2/5. Our next situation, we're only given an ordered pair, and they want us to find the rate of change. Well, now we can use this slope formula. So we're going to begin by labeling this as x1 and this is y1. So everything is in the first ordered pair. We're going to call ones. The second ordered pair, this is x2 and the 9 is y2. So everything in the second ordered pair is labeled as a 2. So according to this formula, we start with the y's. Our second y number is 9. Our first y number is 7 5/10. So I'm going to take away, because that's what the formula says, 7 5/10. So we have this and we have this. Now we're going to go to the x's. x2, we start with 6, and according to the formula we subtract, and we're going to subtract 5. So 9 minus 7 5/10 would equal 1 5/10, and 6 minus 5 would equal 1. So 1 5/10 divided by 1 would just be 1 5/10. Or if you prefer, you could write it as 1 1/2. Our third representation is a table. And if you recall, when we have a table, we're trying to find the change in our y values over the change in our x values. And in order for this to be a function, they all have to be the same. At least they have to reduce to the same. So let's start with our change in y over our change in x. So if I go from my first y value to my second y value, I can see from -5 to -11 I'm going down. So I'm going to write that as a negative number, and that change is 6. If I go from my change in my first x value to my second, I'm going up because I'm going up. 5 to 7 is up, so that's positive, and that's a change of 2. So when I reduce that, that would be -3. So now let's try our next change. So we're going to start with our y values. I'm going to go from -11 to -17. Again, that's going down 6, so it's -6. And from 7 to 9, our change in our x values, that's also 2. They're exactly the same. And our rate of change would then be considered -3. So our rate of change for the first was 2/5, the second was 1 5/10, and this third situation with the tables is -3. So now let's head to the graph. When we find the rate of the change, find rate of change on the graph, we're looking, going from point to point, and we try to locate points that are easy to work with, that are directly on a grid mark. So that's a point, that's a point. There's all sorts of points on that line, but those are the ones that are going to be easiest to work with. And we're going to start the change in y, so it's always a vertical movement over the change in x, a horizontal movement, also known as rise over run. And here's a point too. So I'm going to start at this. I'm going to go up 1. So my rise would be 1. And I'm going to go over 1, 2, 3, 4. Now let's make sure we check. This is a scale of 1. This is a scale of 1. Sometimes they might count from 2, 4, 6. They might count by 2s on either the axis, sometimes by 5. So we have to be very careful with that. So we now have 1 over 4. And we should consistently get this. Rise is 1. Yep, it's positive because it went up. And run is 4. It's positive because it went to the right. So positive 1, positive 4, but we write the 1 first. So the rate of change for this one is 1/4, or 1 over 4. So now let's move on. It says, use your knowledge of rate of change to help you compare the following functions. So I am looking at this, and it looks like they want us to apply what we know about rate of change to be able to solve word problems or real-life situations. Ty sells signs at a monthly craft fair, and he makes 7 signs every 2 hours. His friend Harrison helps him make signs, and the rate at which Harrison makes signs is in the table below. So this is important information. I'm going to highlight that Ty makes 7 signs every 2 hours. His friend Harrison, his information is in the table. So the question is, who is making signs at a greater rate, and how do we know? So using the table, I'm going to call this the X. Hours will be considered X, and the signs will be considered Y. So let's start with what they gave us for Ty. Ty was given just in words, and it says 7 signs in every 2 hours. Well, if we're trying to find the change in Y over the change in X, signs are the Y value, so they mentioned 7, and X is the hours, so they mentioned 2 hours. So 7 over 2. So that's Ty's information. This is his rate of change. Now we're going to move on to what they give us for Harrison. Harrison's going to take us a little bit more work, and we're going to start with the change from 0 to 15. So again, that's the change in our Y values would be 15. And then the change in our X values, that change would be 4. And just to be sure, let's see if we get the same. Yep, that's 15, this is 15, this is 4, and this is 4. So we're going to get the same number repeatedly. Well, these in fraction form cannot be reduced, but we could go ahead and reduce them if we wanted to reduce them and put them in whole number form in order to compare them. So if I reduced 7 over 2, that would be 3 and 1/2, and I found that out by taking 7 divided by 2. And let's move on to Harrison. For Harrison, I'm going to take 15 divided by 4, and 4 will go into 15 3 times with 3 left over out of 4. So Harrison's rate of change is 3 3/4 signs in 1 hour. What we found is a unit rate. And Ty's rate of change is 3.5 signs in 1 hour. Again, that's a unit rate. And as we look at this, the question was who is making signs at a greater rate. So that would be Harrison. Harrison is making signs at a greater rate. He's making a few more signs per hour. Actually, it's fraction, but he's still making more. So let's move on now. Question B. After 12 hours, what would the difference in the number of signs that each friend has made? Well, if we know that these are unit rates, then we're going to start with ties information, and we can use it in fraction form. We can take 7 over 2, 7 signs in 2 hours, and multiply it by 12. Or we could take 3 and 1/2 and also multiply it by 12. So if you want to pause and use your calculator, that's great. Either way, here we would get 84 divided by 2, which would give us 42, and 3.5 times 12 would also be 42. So he'd be able to make 42 signs in 12 hours. And now let's go to Harrison. Harrison can make 3 3/4 signs per hour, or we could also write that as 15/4 times 12 hours, or we could take 3 3/4, both of these are unit rates, times 12. And so pause and use your calculator. Both of these would leave us with 45 hours, okay, or excuse me, 45 signs, and I should have written it for ties, in 12 hours. So if you want to put signs here, that'd be helpful, okay? So continuing on page 20, we're just going to do 2 more, and then we're going to finish up 6 and 9 tomorrow in tomorrow's lesson. So let's focus on number 7 right now. It says compare the slope in each of the equations below. Circle the equation that has the greatest rate of change. Well, just to recall, slope formula is y equals mx plus b. Both of these are called standard form, where they have x and y and the same side equals a constant. This is standard form, and we need it to look like this. So a few lessons ago, we learned how to rewrite this in slope-intercept form. We're going to start. We want y on this side by itself. So we're trying to get y all by itself. So this pesky negative 9x is in our way, and we need the entire term to go away. So we're going to undo it by doing the inverse of negative 9x. We're going to do positive 9x, or add 9x. That's our first solving step. What that accomplished is it eliminated 9x, and we now have positive 3y. And on this side, I cannot combine 27 and 9x, so I'm going to choose to write 9x first, because mx comes first, and then the constant, the slope, the intercept comes second. I'm going to choose to write this as 9x plus 27. I can't make them one term. Now, the second solving step is to continue to get y by itself by dividing by 3, which means I have to divide this entire side by 3. So when we divide 3 by 3, we get our y isolated by itself, and now we have to recall that 9x is being divided by 3. 9 divided by 3 is 3, and my x comes down with it. And then 27, and it's a positive 27 divided by 3, is 9. So our equation should be y equals 3x plus 9, and they ask us to find the rate of change. So right here, this m, this coefficient, is the rate of change. So the rate of change for this particular equation is 3. Now I have to do the same thing for the other equation. We're going to start again by solving. We want this y all by itself, and negative 3x is in the way. We're going to eliminate it by adding 3x to both sides. It eliminates, and we have positive 4y that drops down. 24 plus 3x we cannot make as one term. I'm going to choose to write the 3x first, so this will be in slope-intercept form when we're finished. And now I have to divide everything on both sides by 4. So 4 divided by 4 gives me y. And now this is where it looks a little bit tricky. 3 divided by 4, it won't go in there evenly, so I'm just going to write that in fraction form, 3/4 x. Positive 24 divided by 4 would be 6, so it's positive 6. And so now this is in slope-intercept form. Once again, the rate of change is the same thing as the slope. In the slope formula, we find that, the slope-intercept formula, we find that as a coefficient of x. So it says circle the equation as the greater rate of change, so that is the first equation. So now, seeing how long this video is going, I'm going to go ahead and end for today. Tomorrow we will start at 6, 8, and 9, and then I'll have you do independent practice and use these as examples. Thanks for listening. Have a great day.